Hello, everyone, and thank you for joining us for the Developers Forum, Unlocking Your Organization's IoT Device Management Capabilities with Lightweight M2M. Today's speakers include David Navarro, who is our CTO and co-founder at IoT. We also have Harold, who is Global Head of Business Development at Kraut, and Fred, who is Managing Director at IoT ECC. For today's agenda, we will discuss the history of lightweight M2M and why it's becoming so popular these days. We will also discuss implementing lightweight M2M on the client and server side, as well as lightweight M2M adoption. We will discuss how lightweight M2M works on top of NB-IoT and LTE-M, as well as energy considerations. And we'll discuss key factors if you would like to use lightweight M2M. For housekeeping items, a note that the webinar is being recorded, and the recording will be sent to you as well as the slides a few days after the webinar. As you may have noticed, all of the participants are currently muted, but we welcome your questions and we hope that you will send them through the chat feature for the Q&A session after the presentation. Fred, would you like to start?
Sure. May take a second until I gain control. It worked fine during the practice session.
We'll try again. Fred, can you go ahead?
Yeah, it seems I don't have yet control. Just requesting it again.
All right, how's that?
Now it should hopefully work. Yes, thank you. And thanks for having me today. I will tell you a bit about the history of lightweight M2M and how it developed into a successful IoT standard. My company IoT is offering lightweight M2M tutorials, training, and consulting. Additionally, we also provide consulting related to patent-related aspects of LTE, 5G, and IoT technology. I'm afraid I lost control, but if you like, you can also, yeah, you have still control. You can also just switch the slides for me. Thank you. So what's lightweight M2M in a nutshell? So if we have an IoT asset, for example, a street light here at the left-hand side, communicating with the cloud on the right-hand side, obviously we need a radio access or another kind of access. Quite often it's the cellular access, which is just carrying the bits and bytes in a reliable manner. And on top of that, we have something which is called the service layer. And that's where lightweight M2M sits. So you can update the firmware on your device, but you can also do any kind of service-related functions like changing the dim level or switching on or off the lights. And on the next slide, we will see a couple of device management functions, which you can perform with LwM2M device configuration, diagnostics, connectivity management, and other stuff you need to keep your device operational and configure it according to the environment and the available connectivity. And the next slide will show that in addition to device management, LwM2M also offers data reporting and remote control. What I mentioned before, to manage your asset, to switch on or off machines, or to retrieve sensor data. And everything is packed into one protocol, which is LwM2M. And next slide, please. Yeah, and where did it all start? It started in an organization called the Open Mobile Alliance, which has developed many application enablers for the mobile industry. Like some people might recall MMS, predecessor of our chat services we have today. Digital rights management, location-based protocols, and many more. Today, OMA is mainly focusing on LwM2M. And the next slide shows the OMA are already developed in the early 2000s, and even at the end of the 90s, the first mechanisms to do remote provisioning and management of mobile phones. The first one was a simple SMS-based mechanism called OMA CP, client provisioning, and amazingly, it's still used today in many smartphones. And the more advanced method which was developed after CP was device management, which is a very powerful remote configuration and update protocol, also deployed in millions of smartphones. Next. And it was in 2010 then when the first discussion started about LwM2M, the starting point, as I said, was the OMA device management. So you can see on the next slide, there are a couple of bullets on this early days. At first, people thought that we might be able to enhance the existing OMA device management protocol to cater for machine-to-machine, as it was called at that time, use cases. For example, adding the possibilities to retrieve sensor data and a couple of more things. But a few experts, including myself in that group, thought that OMA DM was too heavy and something radically new was needed. And then the first thought started about lightweight device management. And just on my background, I'm able to explain you the history because I was already part of the group at that time. I was vice chairman of the OMA device management group in the early days, and also the rapporteur and editor of the work item and specifications in the early days. That time working for Vodafone. 2011, the actual work on LwM2M started. And the next slide shows a few bullets on that. The vision was developed to develop a combined device management and service enablement protocol for constrained devices with a low memory and CPU footprint and low power consumptions, to ensure that there's a optimized usage of network resources, and to make LwM2M a horizontal standard which can be used in any industry. Of course, also to make sure there's a high level of security already designed into the standard from the beginning, and to make it developer friendly. And this was actually anticipating the dawn of the low power wide area connectivity, which had not really started yet in 2011. Narrowband IoT only arrived by 2015. However, it was already becoming clear pretty soon that LwM2M may not be only used for constrained devices, but also you can use it in any kind of device, also more expensive and complex devices such as industrial routers, for example. Next slide, please. Yeah, in 2013, after some initial problems to get traction because several companies still thought we might want to evolve with OMA DM. But in 2013, the work became more traction. The first proof of concepts were actually shown at some events with LwM2M prototypes. The first white paper was published and things started moving faster. And this was also accelerated by the launch of Wakayama, the first open source project, which was created by David, one of the founders of IoT, who is also at this call today. 2015, we had the first test fest in Düsseldorf. The test fest is an event which is organized by the OMA in a regular fashion to get companies together, testing their implementations of OMA standards against each other to detect any bugs in the implementations, but also to find any bugs with the actual standard, which are then corrected straight away. And finally, in 2017, LwM2M 1.0, the first release, was published. And yeah, the vision was accomplished to have a lightweight, very efficient, secure protocol, which can be deployed across all industries. And since then, also the adoption started in commercial deployments in smart city metering and many other industries. I will not go too much into the technical details. I'll leave that part for David today. But a little bit on the architecture and on the stack. The architecture, LwM2M, obviously is a client-server protocol. It supports various operations across logical interfaces such as bootstrap registration, device management and service enablement, information reporting, and all these operations happen obviously in a secure and efficient manner. And on the next slide, we see another very important piece of the LwM2M technology, which is the data model. So all the different functionalities which are offered by the IoT device are grouped into what's called LwM2M objects, and each object has its own unique identifier, as have also the resources which are embedded in these objects. They all also have the unique identifiers. And that enables interoperability between the server and the client. So every LwM2M server can does know how to find specific data on any LwM2M compliant client, and does know how to perform any kind of operation on these clients, because this data model is standardized. And here are just few examples. You have the so-called device object with the ID number 3 on the left-hand side, which includes various parameters like model number, reboot, power sources, memory-free error codes. And the server just retrieves information like the model number by sending a get command with a URI 301. 3 is the object ID, 0 is the object instance, and 1 is the resource. So given this data model, the server knows immediately how to find that data. And also the second sample here is the server performs a reboot by sending a post 304. And this data model is extendable. So today you have many hundreds of objects already defined, but if anything is missing for your use case, it's very easy. And it's also supported by tools available to create additional objects. The stack originally with 1.0 was very simple, LwM2M running over CoAP, the constrained application protocol, which you can say is a lightweight version or variant of HTTP. That again is carried over UDP, and DTLS is used as a security mechanism, transport security. Additional transport available with 1.0 was SMS. Yeah, in 2018, the stack further evolved, and as we can see on the next slide, we have added OSCORE, which is a object security mechanism, which is now added in addition to transport security. Then TCP was added because there were some deployments where UDP was not appropriate, for example, due to some firewall issues. And with TCP, TLS was added. But on the right-hand side, we can also see that a LoRaWAN binding was added, and cellular IoT specific guidance was given for using LwM2M over narrowband IoT or CAT-M1, and that also included the non-IP mode of narrowband IoT. 2020, lightweight M2M 1.2, the latest current version, was published. And again, the stack was further evolved, as we can see on the next slide. HTTP as a transport and MQTT, which is already around since more than 2 decades in the IoT space, was added. So it's also possible now to carry lightweight M2M across these 2 bearers. I mentioned in these slides here, the last 2 slides, just the enhancements on the stack, but obviously there were many other improvements in lightweight M2M 1.1 and 1.2, mostly related to further increasing the efficiency in reducing the number of messages which had to be sent to perform specific operations, in changing new and adding new, more efficient data types, data coding mechanisms, and stuff like that. So there were many improvements over these 2 releases of lightweight M2M. Yeah, and today we are 2022. We see already a widespread adoption of lightweight M2M, and it's fast growing. And I have to admit, I'm a little bit proud of that, because it's not guaranteed that the technical standard becomes a success in the industry. We see many deployment examples across industries such as smart cities, utilities, automotive, agriculture, robotics, drones, mining, even some in smart home, or although that was not the original target. And also smartphones implemented to some extent. It's deployed worldwide. And another indication for the lightweight M2M adoption is also that many cellular modem chip vendors already include lightweight M2M in their stack. And this is just a selection of lightweight M2M adapters in the industry. There are certainly several more, and as I said, the number is growing. So this is like several of them, or some of them, are providing the actual support for lightweight M2M infrastructure on the server side, on the client side, software stacks. But most of them are actually companies which have deployed lightweight M2M, which are using it to fulfill their IoT use cases. Yeah, and so what are lightweight M2M success credentials? It offers a lightweight, standardized, secure approach for managing IoT devices and delivering application data to the cloud. It's transport agnostic. It's used a lot over cellular bearers like narrowband IoT increasingly, but also LTE and 5G increasingly. But can also be used over Wi-Fi and other transports. And the third key point, it's developer friendly, extendable. As I mentioned earlier, it's very easy to extend the data model to satisfy your requirements. Yeah, and obviously it allows devices and systems from different vendors to coexist in a growing IoT ecosystem. Last but not least, it's developing continuously in a very open manner. In the OMA, there is ongoing work, for example, and discussions on DLMS COSAM interworking, which is a protocol used in the energy metering space. There are discussions to extending it from a client-server protocol to a device-to-device protocol, which would, for example, allow a motion sensor to talk directly to the light switch instead of going to a server first. Discussions about adding additional transport. There's a new firmware update object version being defined. There is a work item started about bootstrap in cellular networks to use SIM credentials for reliable M2M bootstrapping. And a couple of more topics are being discussed, and everybody can actually join the OMA and participate and contribute to the further evolution of this IoT protocol. Thank you. You might be on mute, Mackenzie.
We can hear you now. Harold?
My problem is my microphone was off.
Okay.
I was so friendly, yes, don't make noise. My name is Harold. Yes, I'm working with Crowd, and I'm 30 years in wireless communication. Crowd is a classic NVO and offering a lightweight M2M server for tests for the customers. And my story today is a little bit about energy and risk savings. Yes, and saving of energy can be done with lightweight M2M, but with other things as well. I would like to show you the part of lightweight M for saving of energy, but some more things as well. So I have some slides. I have just 15 minutes, so I have to speed a little bit up here. Go ahead to the next slide. This is what we offer at Crowd. So we have a lightweight M2M server for testing for our customers. This server can communicate to all the popular clouds like Amazon, Azure, Google, and further. And on the other end, everything what is deeper range is offered by Crowd. We have our SIM cards, and we offer remote SIM provisioning. What means we have the control of the SIM card over the air. I will go ahead here. This is an evaluation kit what I started with business friends. Yes, so in the middle of the evaluation kit is a classic narrowband IoT LwM GPS module. Yeah, so lightweight M2M does not care on the barrier. Yeah, the only what they want is to have a PPP connection. Then we have an MCU on a socket. I showed here several MCUs. All these MCUs are able to run a lightweight M2M spec. And this is a schematic diagram, let's say a block diagram of the board. Here is the NeoWay radio module again. There's a power supply. There is the more than 20 different MCUs. They have all the same footprint. Then I have a standard socket called STEMA QT and Quick. And on this extension sockets, you can get more than 200 different sensors. Several sensors are already on the board. Yeah, and now we come to a little bit to the protocol. Yes, inside of lightweight M2M, we mainly use CoAP Our co-op was the starting point, and as Fred already showed us, we have now the option to use MQTT and HTTP inside of LwM2M as well. However, if you don't use co-op and go to MQTT and HTTP, the energy consumption will rise for sure. This I will show on the next slides. Yeah. And this is one slide that I take from T-Mobile in US. They made some tests and showed what will happen. Here on the top, you see the field strength. It means you see the level of the RF level on the module, and from, let's say, from 90 to 110 dB. The traffic on MQTT is 20 times higher than with UDP. Yeah, and if it comes to very high link budget, that means very low RSI level, and it shrinks a little bit. Yes, then co-op and MQTT will rise. Yes, in energy consumption, but however, the co-op is always better. The reason is simple. In MQTT, the layer behind is TCP. TCP always is waiting for an acknowledge. Even MQTT has an acknowledge. That means we have an acknowledge of an acknowledge. And if we have to a receiving level, then the chance to lose the packet is higher. And if you use plain UDP, or let's say a co-op, then you can tell, I would like to have a transmit without acknowledge only. And if you transmit and don't expect that you get an acknowledge, then the chance to send something is much higher. So worst case, you transmit, the server is receiving, but the acknowledge is lost. That means for the device, okay, no acknowledgement, it has to repeat even if the first message has already arrived. Yeah, a little bit about energy consumption and field strength. We made some tests. We made a study for Deutsche Telekom. The link to the free of charge study is listed under the graph. What you can see is from 134 dB link budget to 144, that means 10 dB more link budget, the energy consumption is just doubling. Yeah, that means we come from 168 to 362 dB. But if you add 10 dB more, yeah, then we already have 15 times more energy. So this is the critical part. And how to save energy. Yeah. As I show on the FOTA slide here, I do it again, 64 byte, yeah, versus 12 byte. And if I make the calculation here and build the delta, then I can see that from the 4,393 milliwatts that we use, yeah, 4,360 milliwatts are already used for the reattach. That means the most energy we need for the reattach. Yeah, other slide with a source from Deutsche Telekom again. The operator was thinking about how to save energy, and you can see here again, as soon you come to the high link budget, the energy consumption in all the stages of the narrowband IoT and LTM will rise. Yeah, what you can do is you have the full control on the link budget on your side by changing the antenna. That means the antenna concept of you, under the place of the antenna and the right antenna concept will dramatically interfere to the energy of your device. You can see it here, 3 dB more or less means we are at 15 kilobit per second, or we are at 5 kilobit per second. If you have a very high path loss, yes, then we talk about 300 bit per second. Yeah, so it is not very interesting to reach the high link budget, because with the high link budget, the energy consumption will rise. Yeah, how to minimize the risk? Yeah, one option to save energy is the remote SIM provisioning, covered by the crowd server. That means by control of the SIM card and by control of the SIM of the IMSI, it is possible to save energy. That means crowd SIM cards are often local SIM cards. That means if we are in North America, we are not on roaming, we are a local SIM card for T-Mobile, AT&T, or Verizon. Yeah. Some more about what is which protocol offering. Fred already talked a little bit about that. David will come back again here. MQTT and HTTP are only transport protocols. Yeah. And they are both on TCP, what means it has a need for acknowledgement. CoAP is on UDP. It has no need for an acknowledge. If you would like to have an acknowledge on CoAP, then you do it on your own inside with the UDP. Yeah, and then you can see that what already Fred has mentioned. You have a device management, you have profiles, you have firmware update over the air. There, you have several things more. Lightweight M2M is much more than just a simple transport protocol. And on top of that, you have the freedom to use CoAP to save energy. Yeah, some more things here. We have ERTX RAI inside of Narrowband IoT and LTM. RAI means that you can tell the modem that it should power off the receiver as soon the message has been sent. Yeah, that means CoAP has the option to tell to send a message without acknowledgement. It means after sending the message, the modem will go to sleep. If you use RAI, yes, you have a good chance to save 50% of the energy. If you don't use RAI and have to wait for an acknowledge, then the energy consumption will rise by 50% because the receiver is open. That means with TCP and means with MQTT, you always have to wait for the acknowledgement. Yeah, narrowband IoT or LTM in a matchbox. Yeah, just a small slide on that. Yeah, there is the true antenna theory. You will find it in the internet. You will also find it on the download region where the other study about energy consumption is listed. Drew was thinking about how small can be an antenna, a dipole antenna. And if you use a monopole antenna, then the second part of the antenna is your ground plane. And you can see for narrowband IoT, or let's say for band 8 and band 20, we need a diameter of 7 centimeters. And if you do the same on LoRa in Europe, we can do the same device only with a diameter of 2.2 centimeters diameter. The reason is simple. The reason is the bandwidth. As more bandwidth you have, I would like to support, as bigger has to be your PCB. That means the lower the frequency and as higher the bandwidth, as more PCB size you have to spend. Some more about energy consumption and let's say antenna efficiency and energy consumption here. You see here two antennas, antenna A and antenna B. Those are chip antennas here, and the second chip antenna is showing you what is the reality. If you shrink the size of the PCB from 120 millimeters to 140 to 120 millimeters, where you have an estimated efficiency of, let's say, 60 to 70% average, and you shrink it down to 50 millimeters, then you have estimated 10% antenna efficiency left. The same has happened here. The only what here is missed, the the antenna supplier is not telling you that you will reach the 10%. And on the left side, you see a simple PCB antenna for narrowband IoT covering one band. And you can see that with a self-made antenna on 71 millimeter length, what is already shorter than here, you are able to reach 70% antenna. That means with an home brewed antenna, you have a chance to get a better efficiency than with chip antennas in the market. Yeah. There are some more examples about antennas that will not go deep in, but you can see we built real modules. So this was a tracker for a sheep, and we did not buy a sheep. We built up the sheep on our own. It was foam filled with water, with salty water. Here we built a street to measure antennas that are should build mounted on the street. We make simulations, yes, and we make radiation pattern tests with our tools as well. Yeah, what you can do to save the energy: avoid MQTT if you can, avoid MQTT and use FOTA. Yeah, avoid non-necessary traffic. The most energy you will save by no transmit. If you don't transmit, then the energy consumption, the energy saving is very high. Remember that from 144 to 154 link budget, the energy consumption will rise by 15 here. And take care if you have narrowband IoT in use that you can use REI to reduce 50% of the energy consumption. If you would like to use it inside of the LwM2M stack, then you have to activate this by AT commands. It means the stack is ready. The REI function is a part of the LwM2M stack. You will find it here. But the specific AT command you have to set on your own, because the AT commands for different modems are not the same. Remember, Chu, you cannot cheat him here. Chu is always right. And the most energy you will save with a good antenna concept. Yeah, that's all for now, and I would like to hand over to David.
Thank you, Harald.
Yeah.
So in my presentation, I will cover the answer to these two questions. If you'd like to use LwM2M, what are the key factors to consider? And how do you implement LwM2M on the client and the server side? So first, a little bit of presentation of IoT Europe. So IoT Europe is a young yet successful company that was founded 6 years ago. And we provide technical solutions for the IoT, and focusing mainly on the device management side of the IoT. Our philosophy is to promote the use of industry standards to ensure the interoperability between the IoT devices that may be constructed by various companies and the IoT service provided by other companies. And in this aspect, LwM2M is one of the key protocol, key standards that we are promoting. So for our products, as I said, there are mainly software products, and we have two main products: Alaska, which is an IoT device management platform provided as a SaaS on the cloud, so where people can connect and manage their IoT devices. And we also provide an IoT client SDK named Iowa for the embedded side of things, to be included in your IoT devices to be managed through LwM2M. So either by the Alaska platform or by any other LwM2M servers that you can use. Our main advantage is that we have deep technical and industry knowledge, being members either on a personal level or as a company on various standard bodies, mainly the OMA. But we are also proud to support our customers at every step of their project, and not just providing them with an SDK and let them do their stuff. So we are partnered with them through all the development cycle and the deployment of their IoT solutions. So currently, the typical IoT system architecture presented on this slide is what is the current status of IoT nowadays, where you have various kind of IoT devices deployed in the field, and they are reporting to the cloud to an application service or a device management platform. When you are focusing on device management, typically you have this cloud platform that control and command the various devices that are deployed. So here we are focusing on the communication between this platform and the devices. When you want to perform device management and answer your business use cases, you have a checklist of features that you must fulfill. So in no particular order, first there is the operation semantic, or the server will interact with the devices. That's something you need to define. You also need to define the data encoding, or the data is exchanged with the device. Will you exchange a JSON payload? Will it be text? Will you define a custom binary format? That is something that you need to define. There is also the data model, or the application data is represented. For instance, if you take a temperature value, will it be transmitted as a floating point value? Will it be an integer value? Will it be a text value? That's something to decide for all your application data. Another item to take into account is the onboarding. Or will you add a new device to your system once it's deployed? Then, for devices that are already onboarded, there is the registration aspect, or device will announce its availability. For instance, if your device is a shipping container going at sea and losing connection, then retrieving connection when arriving in a port, you will need to determine all this shipping container will announce to the device management platform that is available for TM operation. Then you have the discovery, or to know the capabilities of a device. So when a device is registering to your platform, or to determine what you can do with this device. Is it a smart meter reporting a temperature value? Is it a street light where you can control the light and the color of the light? Can you perform a firmware update of this device or not? Can you lock this device? Can you wipe it if it's lost? And so on. Another very important aspect is the security, which cover both the encryption for confidentiality reason, the authentication to make sure that the data you are receiving is really coming from the device you are expecting, or that the control command are really coming from the right management server, and the authorization aspect of things. And then there is all what is covered by device management, which is the configuration, the remote configuration of your device, and how to update software and firmware when needed. So if you take, for instance, a protocol like MQTT, this protocol will cover some of the aspects, like the encryption, the authorization, the registration. but you will miss, there will be things that you will need to develop on your own, like the data model or the data encoding. A good point is that lightweight M2M is ticking all these checkboxes and provide, by design, all these features that you will need, so you can focus on your application use as on your business use case. Sorry. So from a very high level, this is the lightweight M2M concept. On the left-hand side, you have a device like a street light, which is named in this protocol the lightweight M2M client. And this client will expose lightweight M2M objects to the lightweight M2M server. So each of these objects cover a functionality of the device, like the firmware update, the connectivity monitoring, the location, or the light control. And the server will use lightweight M2M operation to manipulate these objects. So the main operation are the read to retrieve some values, write to change the values on the device, the execute operation to invoke a specific function of the device, and from the device you can send notification to the server, for instance, to report change in values. All this operate, as you have seen in the previous presentation, lightweight M2M is working on CoAP or HTTP or MQTT. So for each of this operation, the lightweight M2M protocol defines a specific mapping. For instance, a read operation using CoAP or MQTT will translate to a get operation on a specific URI. On MQTT, lightweight M2M define a specific mapping where you send a specific structure to the device over MQTT. So a very important concept of lightweight M2M is the objects. So the objects are interface for a feature of the device. Like you've seen in the previous slide, the firmware update, the light control, and so on. The objects are presented by the devices to the lightweight M2M server in a way that the behavior and the semantic of the lightweight M2M object is independent of the device and its implementation. So the first benefit is that the lightweight M2M server does not require a deep knowledge of the managed device. Whether the device is a smart meter, a light control, or a shipping container, if the device presents a firmware update object, the lightweight M2M server will manipulate this object in the exact same way on any device. This applies also to all the other objects that are defined. So from a technical point of view, what a lightweight M2M called an object is a collection of resources that are relevant for a particular use case. For instance, if you can define a temperature object that will contain resource containing the value of the sensor measured by the sensor, the units that this sensor value is expressed in, and so on. For each of these resources, there is a very specific and defined semantic, type, and allowed operation. Some resources are readable only, others can be written by the server, some are executable, like for instance, the reboot resource in the device object. For the type, lightweight M2M reuse basic types that are integer, Boolean, floating point value, string, opaque values, and some others. So all these resources, well, first, all the objects have a well-known 16-bit ID. So the device object, for instance, has an ID 3, which helps reduce the number of data that is exchanged between the device and the server. So when a device presents the object 3, the server knows that it's the device object. It knows the layout of this object and the resources that are part of this object. In the same way, all the resources have well-known IDs. Another concept is that the resource and the object can have multiple instances. For instance, in the example on the right, the temperature object has 2 instances, 0 and 1, meaning that this device is featuring 2 temperature sensors. And from the server, all these resources are accessed with simple URIs, which are /object ID, /object instance, /resource ID. So from the server, for instance, if you want to retrieve the serial number of the device, you will perform a read operation on /3/0/2. It is also possible to retrieve a whole object at once by performing the same read operation on /4, for instance. And this will return the content of all the readable resource of the device. So all these objects, as I said, are well-known, and they are present in the LwM2M registry. This registry is maintained by the OMA SpecWorks, the standard body that designed LwM2M, on a public URL. So in this registry, you will find objects that are answering most of the device management use cases, firmware updates, device lock and WAP, connectivity monitoring, and so on. But you will also find objects that are defined by other SDOs, like the IPSO Alliance, which defined several dozen of objects related to sensors, like temperature sensors, light controls, and so on. Others SDO also define their own objects, like the GSMA, for instance, or the 3GPP, that are relevant for the use cases that they are addressing with their standards. But individuals and companies can also register their own objects that they find relevant for their business use case, and they think can benefit other players in the industry. So let's take an example where the device you want to connect using LwM2M is an automatic door. On this device, you will find 2 present sensors and a powered sliding door. And from a business point of view, you want to be able to control the door and override these automatic features, being able to disable the entry or the exit, and count the number of activation. So the first things you do after integrating a LwM2M protocol stack is to look for the relevant LwM2M object for your use cases. By looking in the LwM2M object registry, you will find the presence object that was designed exactly for presence sensors. So this object has a well-known IDs, as I said. In this case, it's 3302. and it features several resources. First, the main resource is the digital input state, which is a Boolean resource, and it indicates if the present sensor detects someone or not. As you can see, this resource is mandatory, meaning that every instance of the ipso presence object presented by any device will have this resource. The other resources are optional. So depending on your device, you can choose to implement or not the other resources. So here you have a digital input counter as an integer, which is, we count the number of activation. And for our use case, that's a resource we want to implement. The next resource is an executable resource, which is there to reset the counter. So by performing an execute operation on this resource, the lightweight M2M server will reset the value of the digital input counter resource. You also find a string resource, sensor type, which is there to describe the sensor. And then two resources to configure the sensor, which are the busy to clear and clear to busy delays that the server can modify depending on the use case that you want. But by looking at in the lightweight M2M registry, you will not find any objects that will really fulfill the use case of the door control. So one thing of the lightweight M2M protocol is that it's extensible, and devices can implement their own lightweight M2M objects. So to fulfill our business use case, we'll need to create a new lightweight M2M object. So one of the things is that the lightweight M2M server must know the object layout to be able to manipulate it. And when you define your objects, you will need a unique object ID. And to avoid collision, the lightweight M2M in its registry defines several ranges, like it is done for UDP and TCP ports, for instance. So as I said, these IDs are 16-bit IDs. So they go from 0 to 65,544, because the last one is a reserve value. And you have several ranges. So the first one is for objects that are produced by the OMA. Then you have another range for objects that are registered by other standard organizations. As I said previously, companies and individuals can register their own objects in another specific range, but you can also reserve some IDs for your use without publishing the objects. They are if they are sensitive, but you must ensure that there is no collision with other devices in the field. And then you have a range above 42,000, which you can use freely, but with the risk of collision if you are deploying on an open system. So with this in mind, we will define a door control object. And to fulfill our business requirements, we will first have an integer resource which reflects the door opening states. So by specifying that the unit is over 100, it's basically saying that we are using a percentage. So 0 means the door is closed, and 100 means that the door is fully open, with all the steps in between. This resource is read-only from the server. and we mark it as mandatory. Then there is another resource, which is Boolean, which is the automatic mode. So if this resource is true, it means that the door is working in automatic mode. And if false, it means that the door is controlled by the LwM2M server. So this resource is readable and writable by the LwM2M server. And then we have to control the door opening, we have a set point resource, which is writable also, and has the same semantic as the door state resource. And for configuration, we can define also a closing delay in milliseconds so that the server can control the speed at which the door will close when it no longer detects someone. So with this object or device, the automatic door will present two instances of the presence sensor. So the first instance we will specify in the application type that it's the indoor sensor, and in the second instance we will specify that it's the outdoor sensor. And then we will have one instance of our newly defined door control object. So there, from the server, if you want to know if the door is open or closed, you will perform a read operation on the door control state resource. And if from the server you want to close the door, you will switch the mode to false by performing a write operation, and then you will write the set point resource to 0, that means fully closed. And you will receive a notification from the device containing the state of the door control to 0 when the door is closed. So the key takeaways is that the LwM2M protocol covers all the required features for communication and device management in an IoT system. When using LwM2M, you know that you will address the security aspect. You will be able to add new devices afterward in your system, and the data model is well defined, allowing you to either from the server manage devices coming from various vendors, or knowing from the device that you can connect to any LwM2M server and be able to fulfill all your business use case. And this is done mainly by the LwM2M object, which offer a unified interface to the device features. It's a unified and standardized interface. So when you decide to use LwM2M as a device vendor or as a designer of a new IoT system, the most important part is to select the right LwM2M object for the task, either by reusing a registered object or by designing your own object. And designing your own LwM2M object is easy. And that will conclude my my presentation. So now we will address the question.
Yes, David, thanks for that. So we have a couple of questions from people. So I'll let you maybe start by the two first one from Alexander's on how RESTful approach is used in LwM2M and about utilization of patch and delete HTTP method. Okay, so I will take this one.
So as I said, LwM2 in the LwM2M protocol, there is a mapping defined to CoAP and HTTP that are RESTful protocol. So during the life cycle of the device, by presenting the object will be mainly a RESTful server, and the LwM2M server will be a RESTful client. But as Frieden presented, there's other interface used for the registration for the bootstrap phase of the device, where this is inverted, and the LwM2M client, the device becomes a RESTful client, and the LwM2M server is a RESTful server. So yes, LwM2M reuse the RESTful concept, but some may argue that it's not a fully RESTful protocol because of this registration phase and so on that are required for smooth operation of the IoT system. So and yes, the mapping of the function reuse the patch and the delete HTTP and CoAP method. So I did not cover in my presentation all the existing LwM2M operation for the sake of clarity, but know that there are other operations like creation and delete and deletion that are used to create or delete object instances. And the last one is using the delete method. And the patch method is used when you want to write several resource values among several objects.
On another question, Alexander is asking, what is the typical RAM and flash footprint of LwM2M on top of CoAP and MQTT, and what is more compact variant? So maybe you can answer here from your hat, your IoT Europe hat first, because RAM and flash does vary in terms of LwM2M implementation. We are 10 times smaller, so please take the example of IoT Europe rather than others, but it can be helpful to go on to that first example of IoT Europe size first.
Yes. So the short answer will be it depends, because LwM2M defines several mechanisms that are optional to use. And for instance, for the data encoding, LwM2M make use of several data encoding, from a very compact one, like LwM2M Sabre, to a more verbose one, like the SNML JSON, for instance. So it depends if you want to, on the device, if you want to support all the formats or only one specific format that will answer your needs the best. But if we are not taking account CoAP and MQTT, typical LwM2M implementation will be about 10 kilobytes of footprints. And you're asking what is the more compact variant for this. So I'm not sure exactly what you mean, but as I said, you can choose to support only some specific data formats, for instance, or all of them. And obviously, from a footprint point of view, LwM2M 1.0 will be more compact because it has less feature than 1.1 or 1.2.
So and to a typical size, it is about 40 kilobyte for IoT Europe stack, and in terms of flash, and 5 kilobyte of RAM. Maybe Harald, you want also to take that question, so maybe provide some feedback on that question. Harald, are you with us? Or is your mic connected?
I'm still here, so
Yeah.
I did not catch your question.
So the question from Alexander was, what is the typical RAM and flash footprint of lightweight M2M on top of co-op and MQTT, and what is more compact variant? So
yeah, as I know, I'm more on the hardware related, but MQTT or co-op are only transport protocols. Yes, they forward you a message. Yeah. Lightweight M2M is much more. Yeah. So you have the device management, what you miss in MQTT. You have the software update. That means each feature what you add on top of MQTT will rise the memory footprint. But if you don't use lightweight M2M, you have the freedom to do it on your own. Yes. How big will your own code be to manage your own device management? How many time you will spend? So I give the question back. Yeah. So lightweight M2M is solving a lot of problems. Yes. And if somebody is doing this all on their own, they talk about many months of work, yes, many years maybe. And if they are finished, they have to support their own code for the next 10 years. Yeah. So to do it on lightweight M2M is much faster and much cheaper.
Yeah, so totally comprehensible. But comparing a stack like lightweight M2M, which is not only a transport protocol but also a device management protocol, is difficult. And it's also difficult to compare a protocol like MQTT, where the payload is not defined, to a protocol like lightweight M2M, where you have a definition of objects and you can think about the long term, because there is already definition and specification for data. Thanks, Harald. Fred, there is a question I'd like you to address from Alexander still. Is lightweight M2M suitable for lightweight Bluetooth on any on edge devices like battery-powered sensors?
Well, I'm a cellular guy. I haven't worked with Bluetooth in my life, but I don't see why not. We have these very light versions of stacks. And we have definitely lightweight M2M also being used on battery-powered devices. But I don't know if David has experience with Bluetooth and may be able to help more.
David?
Yes. So yes, lightweight M2M is suitable for Bluetooth, using the Bluetooth as a transport. And for battery-powered sensor, the answer is also yes. So obviously it depends on the size of the battery. But yes, we have a successful deployment on very constrained devices powered by very small batteries.
So thanks, David. Here a question for IoT Europe, about the lightweight M2M implementation in IoT Europe. I'll answer that quickly because the lightweight M2M version in IoT Europe, Iowa SDK, and also available from Alaska, is the latest version, 1.2. And it's not, there is no version 2 of lightweight M2M as far as I know. So I don't think there is more to say on that. So I'll drop directly to the anonymous question. So about bootstrapping process. Is it possible to change the bootstrap credentials after a successful bootstrapping to prevent anyone from using the default factory credentials? And it's a question, I think, for David on that.
So the answer is yes, of course. So the bootstrapping process is when the device is first on its initial run, will contact a dedicated lightweight M2M server, which is the lightweight M2M bootstrap server. And this bootstrap server is in charge of providing the device with its credential to connect to lightweight M2M servers. And during this process, the bootstrap server can also override the credential to the bootstrap server and replace itself with another bootstrap server. So it's a very common process in the factory floor to flash the device with credential to one Bootstrap server. I would say the device vendor Bootstrap server. And when the device is deployed in the field, it will contact this device vendor Bootstrap server. And depending to whom the device was sold and who is deploying and operating the device, the vendor Bootstrap server will provision on the device the keying material to connect to the operator Bootstrap server. And in this process, as a lightweight M2M device can have only one Bootstrap server provision, the device vendor Bootstrap server will be deleted from the device. And from now on, the device will only know the operator Bootstrap server.
Thanks, David. Again, I think, sorry to be always on you, David, but I think it's always very, except if Fred feel it's okay for him, but we have a question from Juan Roste. Have a lightweight M2M user interface for operate the information from the devices. If we talk about the smart lighting use case, which you presented, David, can I replace the CMS with a lightweight M2M server?
So one thing is that lightweight M2M protocol scope is only the interaction between the lightweight M2M server and the devices. So there is the lightweight M2M standards does not define anything about the lightweight M2M server user interface. But it is totally possible to replace the CMS in a smart lighting use case by a lightweight M2M server, knowing that you will have to develop some application server on top to answer all the features that were provided by the CMS.
Thanks, David. Again, still in the lightweight M2M firmware update, a question from Paul, whether it should be point-to-point or can it be multicast? To you, David, again, I think that it's also very much in the specs of lightweight M2M. I think you...
So during the lightweight M2M firmware update process, there is the phase of the new firmware payload delivery. And if you are using, there is two methods currently existing. One where the lightweight M2M server will push this payload to the device. And when another method is where the lightweight M2M server provides an URI for the device to download the payload from. So in for the first method, where the server pushed the payload to the device, we are depending on the application protocol that is used beneath, CoAP, HTTP, or MQTT. And with CoAP, there are currently some work in progress to perform a multicast delivery, a secure multicast delivery to a group of devices. But that's something that is not yet finalized from a standardization point of view, but that will be integrated in lightweight M2M when ready. For the other method, where you provide URI for the device to download the firmware payload, you can rely on other protocols than CoAP or HTTP, allowing you to perform some kind of multicast.
Thank you, David. Yuri, I will not forget your question, but in order to a bit have Harald also a question. So there is a question to Harald from Philippe, which is just to make sure I am the right understanding. NB-IoT RII setup means turning device in push mode type only.
Yeah, I've seen the message, question. Yeah, this is true. That means if you activate REI, yeah, That means the device is transmitting, and after the message is transmitted, the device will go immediately to sleep and will not open a window for listening to an incoming message. This is confirmed to co-op, because inside of co-op you can tell it is a co-op with acknowledge or it's co-op without acknowledgement. Yes, if you say I send a message here on LwM2M, I don't expect an acknowledgement. I would like to have an acknowledgement. Then you can activate in this part of the code already REI.
Thanks, Harald. Another question to you, still from Philippe, that you present a prototype of flexible antenna in your slides, Harald. Did the antenna work? Would the antenna work for textile, for wearers usage, for wearable? If yes, what would be the frequencies addressed?
Yeah, the antenna in the photo is a flexible antenna. It was made for 5G on 3600 megahertz, and this is flexible because there is a very high vibration. Let's say any ceramic antenna will break immediately. Yeah, so yes, if he email me, we can discuss antennas about textile usage. My team made a lot of funny, very, let's say, specific, non-common antenna designs. Yes, I put this in because it is, let's say, a little bit different from all the others that you normally see on the market.
Thanks, Harald. And I'll put you in contact with Philippe.
Yeah.
Fred, I'd like to give you two questions. So the first one is the question from Edong Wang. Thanks for the presentation. In the table which compares the different protocols, it seems that LwM2M has all advantage compared to others. That it means that LwM2M can replace others as MQTT, co-op. What are its limitations? I'm not sure if it was in your presentation, actually, Fred, but maybe you can answer that one.
Yeah, sure. It's not about replacing co-op, first thing, because LwM2M usually uses co-op as the underlying protocol, so it's one layer higher. And LwM2M also may use MQTT. But it still depends on your use cases. So you can solve actually all your use cases with LwM2M, but there might also be very simple IoT use cases where you would just carry one bit of sensor information from a very simple device, which doesn't need, or at least you think it does not need, any device management. Then you could also continue to use, for example, MQTT or co-op. Co-op obviously has advantages over UDP and advantages over low power but area networks compared to MQTT. So it's still possible for specific use cases, obviously, to use only MQTT or use co-op. But for most use cases, we also need some kind of device management, and neither MQTT or co-op alone give you that. Therefore, it's recommendable to think about deploying LwM2M to satisfy also the device management in addition to your application management use case.
Thanks.
Right, I'm writing right now a text to a customer here. The customer is for ages in the sensor business, yeah, is making analog sensors, yeah. So the sensor on its own will never get a software update because there is no software. There is a gateway there, and they developed an own gateway, and behind the own gateway they have their own cloud. And they asked me this week, Harald, what can we do better? My answer was, take your own gateway away use a standard gateway on Linux with a mini PCI slot with an M2 slot. Put the two modems in, that means their own wireless protocol on 868 megahertz, 5G or 4G modem, and put on top the lightweight M2M stack, and they are finished. They are finished with device management, software update over the air, bootstrapping, and so on, and so on, and so on. That means all the problems are solved by taking the own gateway away and to replacing it to a standard gateway with lightweight M2M. They have not to think about software updates of the stack anymore. If you develop your own device management, then you have to support your own device management for the next years. And you showed us the history of lightweight M2M, yeah? Version 1.0, 1.1, 1.2, and there is more features and more features and more features. And yeah, if you would like to have a new feature in your own, let's say, device management, then you have to develop it on your own, or you use lightweight M2M.
Absolutely, and you are kind of locked in with your proprietary software. If you want to get the new devices into your IoT infrastructure, then you have to implement your own code, and you can just take off the shelf.
This gateway is then able to communicate with. You could see that on my slide. It could communicate to Amazon, it could communicate to Google, it could communicate to Microsoft Azure on several more cloud services are already implemented in the market. And if you make your own cloud, yes, and go tomorrow to a big customer here and say, I would like to sell you my device, I have my own cloud service, then they will tell you, sorry, but all our devices are already on Amazon, so please be so kind of support Amazon. With lightweight M2M, this step is much easier, let's say, to make the customers happy that already have some kind of cloud services in use. If you would like to use to make your own add-ons on a cloud service, then why to develop an own cloud if you can use the extensions of the big players that are already on the market?
Thanks, Fred. Thanks, Harald, and thanks, Fred, for your answers. Putting your IP hat, your intellectual property specialty, Fred, because you do also intellectual property. There is a last question from Alexander about the licensing limitation with lightweight M2M. I'm assuming that he's not speaking about lightweight M2M commercial applications, but lightweight M2M as a specification. So I'd like to give you the ball.
Yeah, but there's another one about sleeping devices, right?
I'll address at the end if you don't mind. And I think that it is the last questions. Are there limitations with lightweight M2M? I'll go to Yuri at the end. Sorry, Yuri.
Yeah, well, I didn't see any licensing limitations with lightweight M2M. Also, talking about patents, I see lots of issues in the cellular space for LTE and 5G, but I haven't seen any issues with lightweight M2M so far. But if you talk about other licensing aspects, open source licensing and stuff like that, so maybe IoT, since you are building the code and developing the software, maybe you have something to add here.
Yes, so the lightweight M2M specification itself, as we said, is written by the OMA SpecWorks, which is a standard development organization using the FRAND model, so fair and reasonable and non-discriminatory. So that means that if any members that is participating in the development of the lightweight M2M specification is obligated to declare any patent that they may have on some aspect of the specification. So currently there are only 3 or 4 declarations that are done on really some fringe aspect of lightweight M2M, and one could argue if they really apply to the lightweight M2M specification. Anyway, yes, if you are a member of the Open Mobile Alliance, if you want to implement lightweight M2M, you are covered by the IP policy of the OMA. If you want to use lightweight M2M and you are getting it from vendors or service providers, then all these licensing aspects are covered by the vendors or the service provider.
Thank you, David. And now to Yuri questions. Thanks for your patience, Yuri. It looks like the IoT devices, like the M2M client, must be listening to the server request, read, write, etc. How is lightweight M2M implemented in very energy limited devices that follow the next steps? One wake up from low power state, switch on the COM radio, and then go to sleep again. Maybe you can take the point, David.
Yes. So that's something that is present in the lightweight M2M protocol since its beginning, and there is a very well-defined process for such devices. So basically, when the device gets out of wake up from the low power states, it will contact in a very short message the lightweight M2M server, basically asking, do you have any command for me? And if not, then it will go back to sleep again. So to lightweight M2M in this aspect will cover some things that are not defined for a co-op or MQTT device. And it's that sense that lightweight M2M, as Freedom says, is reusing co-op and MQTT, but filling some hole that were present, like the data model, as we said previously, but also this kind of process that are not standardized in when you are using co-op or MQTT.
Yeah, so this is called queue mode, right, in the specification of lightweight M2M. So any messages which are sent to the device, any requests are queued on the server side until the device informs the server that it's awake again. This is one aspect of it.
Okay, I'm not seeing any more questions. I think that we are 30 minutes beyond the schedule. I'd like to first thank you all to attend. I'd like also to thank Mackenzie Minch for organizing and preparing everything. And I'd like to thank, of course, Fred for his participation and his great view, and Harald for all its knowledge about the hardware sides, and not only lightweight M2M, but narrowband IoT, and of course David. So thanks all for your participation. We will have a webinar coming up soon in October with our partners, IoT creators. I'll tell you more in a few days. Thanks everybody.